we're gonna work on what we call R squared, or our coefficient of determination, what we call R squared. So there are specific conditions in here that we need to look into. The first one is this, right? It says in here that the total deviation is equal to the unexplained deviation added to what we call the explained deviation. So what are those terms in there, right? Y bar in there is what we call the mean of y, our response variable, okay? Y hat in here is the regression value of the response variable, all right? So if you can recall our regression line, that y hat is the response variable value of that. And y in here is the observed actual value of that response variable. So as you may notice in here, everything in here is based from the y. The independent variable in statistics is called the response variable. Good, right? Now what is the meaning of R squared? So as you may notice in here, since the total deviation is equal to the sum of the explained deviation and the unexplained deviation, this is what we call the definition of R squared, or what we call the coefficient of determination. That is the what? That is the proportion of the total, the proportion of the total variation of the response variable y that is explained by the regression line. Okay, so once again, that is the proportion of the total variation of y explained by the regression line, which is our y hat. Okay, so as you may notice in here, there are three different regression lines. Okay, so here it is. As you may notice, there are three different regression lines. And consider those are the least squares regression line, and those are the actual points. As you may notice in here, in this case, your dots or the scatter plot hits the regression line almost exactly in there, right? So what does it mean? So letter A in here means what? Okay. Letter A in here tells us that 99.99%. So in here, our R squared is what? 0.9999, right? Times 100%. What does it mean? That 99.99% of the variability in y, whatever that our response variable is explained by the least squares regression line. So again, that is what the implication of your R squared is. You multiply it by 100%, then that means that percentage of the variability in y is explained by the least squares regression line. So again, R squared. Okay, so again, you always multiply that one with 100%. Now, how do we analyze this, right? So let's consider this particular problem, and let's read this one in here, okay? So let's read this, what we call tornadoes, right? So here it is. Let's read this tornadoes problem, okay? Number 15, okay? Liana, let's read this number 15, please. Thank you.
Is the width of a tornado related to the amount of distance for which the tornado is on the ground? The data represents the width in yards and length in miles for tornadoes in Louisiana in 2017 and are from the file Tornadoes 2017 that we have been analyzing throughout the course.
Thank you. All right, so what do you think is the what we call the explanatory variable, and what is the response variable according to this problem, right? So which one, according to this correlation study, which one is the explanatory variable and which one is the response variables? As we may notice in here, the width of the tornado is the what we call the explanatory. That's the x value, all right? That's the x value. However, we'll see now if that width is what? Again, this is not a causation. We will see if there's a possible correlation between this width and what? The length. Okay? The length where or the amount of distance for which the tornado is on the ground. Okay, good. So, explain why this data should be analyzed as bivariate quantitative data. Well, we can open that one already and let's see, what do you think is width and length? What kind of variables are they? Are they qualitative or quantitative variables?
Quantitative.
Quantitative, very good, right? They're quantitative variables. Well, there are two types of quantitative variables as well. Are they discrete or continuous?
Continuous.
Continuous, right? Very good. So with that being said, they are continuous quantitative variables. Bivariate, there are two variables, x and y. So yes, they are all bivariate quantitative data. So yes, we can use our Pearson product moment of coefficient. We good? Right? Letter C. Let's read letter C. Go ahead, Obi.
Draw a scatter diagram of the data. What type of relation appears to exist between the width and length of a tornado?
Okay, so again, the width in here is the x, and definitely that's the explanatory variable, and the response variable is the length. Get it? Okay, so let's see. How do we do this? So let's open our StatCrunch. So if you go to your StatCrunch, click on the data set from your textbook. We're going chapter 4. What question number is that on chapter 4.3?
15.
Did it say 15? Okay, so click on that 4-3-15, and here it is. Okay, so let me just go ahead and X this out. So again, this basically confirms that the length of the tornado, right? Okay, meaning how many miles, right? Okay, it had been on the ground. Okay, and the width, right, of the tornado, right? As you may notice, they're both what? Quantitative, continuous variables. Okay. So how do we do this? Once again, similar to what we have done in 4.1 and 4.2, right? Which is what? Where do we go?
Graph.
Stats, right? Okay. Go to what? We're going to regression, right? Okay. And what kind of regression are we looking into?
Simple linear.
Simple linear. Very good, right? So again, stats, regression, simple linear. Here we go. Okay. What's our x variable again? What's the explanatory variable? Width. Thank you, right? So check on the width. Definitely the length, right? The distance to which it actually, stayed on the ground. That is the y, or response variable. Where is that one? Length. See that one, guys?
Yeah.
Okay. We're gonna go to make sure it's a fitted line plot, right? So that you would already see the least squares linear regression line. Okay. The x-axis label, what do we put in here once again? What's our x-axis?
Width.
Explanatory variable.
Width.
The width, right? Thank you. Width of tornado, right? The y-axis is the what?
Length.
Is the length. Thank you. All right. And we can put in there the title. What is this? The regression line. Of tornado. Width and length. Okay, guys. Okay, so we're trying to put in some explanation in there. Click on compute, and let's see what we got in here. So here's our data. Okay, so first of all, what is our Pearson product moment correlation coefficient R? How much is it? So again, we're gonna put in here the tornado, right? Tornado, right? So what's your R, or the Pearson product moment of correlation coefficient? 0.579, right? So that one in there, it's our R, 0.579, approximately. Okay. What is our sample size, by the way? For the tornado, the sample size is, there are 87 data set. Okay. In short, there are 87 tornadoes that were analyzed. Okay, according to this one, right? So that's our R. What now is our linear or regression line, right? So what's our linear regression line? The least squares linear regression line. Did it say in there? Let's verify. It is in here. How is it, guys? All right, that's our linear regression line. It says what? Your y, that is your length, okay, is equal to how much? What's the slope? The slope is 0.0049, right? So that is your slope, right? 0.0049. 0.0049 x, and x in here, by the way, is the width. Get it? Okay. And what is your intercept? Your y-intercept? It says in here the 1.628. Get it? All right. So again, it depends on how it says to be like rounded off to, right? So if it's 3 decimal places, that's 1.628 as a y-intercept, right? So in here, plus 1.628. And again, that is the what we call that y-intercept. So let's make it clear. This is the slope, and this is the y-intercept. Get it, guys? Okay. So what does it mean? So the slope means what? 0.0049. So this is what? Tens, hundreds, thousands. So if you can approximate to what? We can maybe approximate to what? 0.005, right? Or what we call 5 thousandths, right? So if it's 5 thousandths, what does it mean? What does it imply? That what? An increase, right? This is an increase, right? An increase of what? 1 unit in x, right? Which is in width, will lead to what? Leads to how much of an increase? 0.005 in length. Very good. So right, when you say 0.005, that means what? For every 1 unit increase in x, the width, your increase in the length is how much? 0.005 units. So whether that be in miles, I think this is in miles anyways. Are we good? Right? And also in that case, you can also say that what? An increase of what? For every 1,000 increase in the width, you can increase how much? 5 units in length. Get it? So either one or the other one, they're basically the same. Are we good, guys? Right? So get it? Okay. What's the y-intercept? Yeah, okay. Does it make sense? The y-intercept, does it make sense in here? Honestly, I would say it doesn't make sense because honestly, if your width is 0 anyways, then that means you don't have a tornado to start with anyways, right? So I would say the y-intercept in here doesn't make sense. But just to give you an idea, right, that what? If the tornado width is negligible, right, in size, the y-intercept is just that, right? It's just gonna be like what? 1.6 miles on the ground, okay? It's gonna stay 1.6. Again, but it doesn't make sense because honestly, if the width is 0, there's no tornado at all. Are we good? Get it, guys? Okay, let's go back to our, some more of our analysis. Okay, one last, by the way, in here. What is R squared? What is R squared in here? Since we are already on the given in here, what is R squared given? So R squared in here is given to be how much? Let's color it blue. Okay, R squared, where is that?
0.35.
Thank you, right? So that's 0.335. What does it mean? So when you say R squared is 0.335, if you multiply it by 100%, right? Then that means what? Then we can say 33.5%. Very good, right? 33.5% of the variability, right? Again, 33.5% of the variability in the response variable. What is your response variable again?
Distance.
Length, right? So 33.5% of the variability in length is explained by the least squares, right? The LS, let's call it LS, least squares regression line, right? Again, what does it mean? That this least squares regression line accounts for what? 33.5% of the variability in the Y or response variable in here, the length to which it is actually stayed on the ground or that tornado. Are we good? Questions, guys? So basically, that is the essence of R squared. R squared times 100%, that means what? That much of the variability in the response variable is accounted for or explained by the regression line or the least squares regression line that we have just got from the StatCrunch. Get it? Okay. Now, let's see the data set. So how does it look like? Mr. D, it says about the scatter diagram. What is the scatter diagram? If you click on the right, here it is. All right. So that is our scatter diagram. As you may notice, the strength or the strength of correlation in here is what? Weak. Right? So we are assuming that this will not be what? This will not pass the critical value. But still, you know, it's a good analysis for us. Get it, guys? Okay. And the last one. Okay, last final questions or final set of questions for such, right? We have not yet done interpolation or extrapolation, predicting values, right? Either present, existing values, or future values according to the data set. So let's go back and let's see where that data set is. Where's that question? Okay, here it is. So we have found out the correlation coefficient is 0.579. It says in here yes, but still it's not too strong of a correlation, right? 0.6, okay? Find the least squares regression line, so that's it. Y hat is equal to 0.0049x plus 1.628. And again, we have explained what the slope and the y-intercept means. Predict the length for tornado whose width is 500 yards. So I think this is what? Did it say is width or is in yards? Can we go back to the data set?
Yards.
Did it say yards?
The data represent the width in yards and length in miles.
Did you notice that one, guys? Let's see.
It's just in the middle.
In the middle, right next to file 4315.
Thank you. All right. So
On the right.
Yeah.
Oh no, it says in here this is okay. So the width is in yards and the length is in miles. So they are, as you may notice in here, they are two different units. Okay. So that also explains our slope a while ago, right? So on our slope a while ago, we can say that what? An increase of 1,000 yards in width, right, will lead to how much? 5 miles increase in the distance or the length to which it stayed on the ground. Okay, so once again in here, the x is in yards, the width, but the length is in miles. So it's a pretty good note to consider that they are two different units of measurement. Okay, so going back in here, predict the length of a tornado whose width is 500 yards. So that means this 500 yards is the what? That is the x, right? Okay, so we can basically just use our decimals to see how much that will be, right? So y is equal to, what's our formula again? 0.0049, 0.0049. What's our x again? How many yards it says?
500.
500, thank you. 500 yards plus, what's our y-intercept? It says 1.628. 1.628. Good. So it says that what? A tornado having 500 yards of width is predicted to travel how many miles? More than 4 miles, right? More than 4 miles on the ground. Are we good? Right, so that's our what we call a prediction for such.
Okay.
Next one. Again, if 500 yards is within the range of your x values on the stat crunch, then it's interpolation. But if this is beyond the scope of the range of your x values, then that is called extrapolation. Get it? Okay, so those are the only two different what we call terminologies for such. What's next? What's the other question in here? Okay, letter H. Let's read that letter H, okay? Robbie, go ahead. Let's read letter H. What's the tornado?
Was a tornado whose width was 600 yards and length was 10.09 miles on the ground longer than would be expected.
Okay, yeah. So 600 yards and length was 10.09 yards. Was it longer or shorter than expected, right? So we'll see. 600 yards. So we're going back to the data set, and instead of 500, we're gonna put in here what?
600.
600. Thank you. Okay, just change this 500 to 600. How much did we get? We only get 4.5. So it's expected to just be on the ground for like how much? 4.5 miles. More than, basically, right? Approximately 4.5 miles, 4.5 miles. But in reality, it turned out to be what? 10.09 miles. So it's what?
Longer.
This is definitely longer. By how much? Well, 10.09 minus, what's that?
4.568.
4.56, right? So let's put it in here. 10.09 minus 4.568, right? Oops. 10.09. Okay. 5.5. Okay, guys. Okay, so there we go, right? Let's continue. What does it say here? Letter J. Let's read letter J for such. Caroline, go ahead, explain.
Explain why it does not make sense to interpret the intercept.
Thank you, right? And we just explained a while ago, right? The intercept is the value of what? The length of the tornado if your width is what? 0. Well, first of all, if your width is 0, honestly, there's no tornado to begin with. Get it? Okay, that's why it doesn't make sense that y-intercept. But, just to give you an idea of how the trend actually goes. Get it? Right. Okay, letter K, right? Let's read the last question in here. I think we have answered this one already, right? Kalina, go ahead. What proportion?
What proportion of the variability of tornado length is explained by the width of the tornado?
Thank you. And we just explained a while ago, 33.5% of the variability in length is explained by the least squares regression line. And again, we got that one from that r squared. Whatever your r squared is, you simply multiply that by 100%, right? 100%. Get it, guys? Okay? And that basically is, that last question is the only thing that is the implication of our lesson for today. The rest is basically what? 4.1, that's your R, Pearson product moment correlation and its implications, right? 4.2, that is the predictions, interpolation, extrapolation, and the linear regression line itself. But the last question, that is the 4.3, right? Again, percentage. R squared is the percentage of the variability in Y, response variable, that is explained by the least squares regression line. Get it? All right. Thank you, and we're gonna